Morning, everybody. August 11th, our last scheduled class session before we break out and work on capstone projects. And today I'd like to welcome Mr. Justin Rowan. He's our administrator for the MariaDB instance that we've been working with so many weeks in Workbench. And just an AWS guru. And Justin, you had said your role had changed. I'm curious to hear about the update. But anyway, the topic this morning is Git and GitHub. Little piece of software you can install on your workstation and a website that does version control. If you're not familiar, even as analysts, you guys are developing software products, and Git and GitHub has been used now for years as pretty much the premier way to do version control of all the different pieces of a software project. And as analysts, you guys have the main file that you're using for analysis, but you've also got, test data sets that verify things, and training data for machine learning models, documentation like entity relationship diagrams, all that sort of stuff can become kind of a hairball if you just throw it out on a shared drive and don't maintain some semblance of order over it. So this is the way the software engineers do it. Like I said, if you're not familiar, a lot of projects out there, tutorials and whatnot, implement Git and GitHub. Pretty much every data science tutorial program that I've seen has you create a presence, a repository on GitHub and get going. So yeah, it's definitely a big part of the software world out there. So welcome, Justin. Appreciate you taking time out of your day. And I need to enable all participant sharing. There you go. So you should be able to share your screen and take it away. This is what, at least the third time you've done this for me.
Yeah, something like that. Maybe more.
Maybe more.
It's hard to remember. Yeah.
Okay. Take it away, Justin.
Will do. Okay. Yeah. So like Don said, my name is Justin. I work at Axiom. I've been there for coming up on 13 years now. Primarily as a developer. My role has shifted a little bit more into an architecture role, but what we're going to go over today sort of transcends any particular job role. So yeah, software development is kind of the core use of version control, but like Don mentioned, even as analysts or tech writers or anything where you want to maintain a version history of something you're working on, you might find use here with Git. So I don't know the full extent of the course that you guys have gone through and what you've done so far that you might find that this benefits, but I'm sure by the end of it, you'll probably recognize something that you could get some value out of this.
Well, sure, I can catch up on that real quick, Justin. We've covered SQL queries, which you can save off as a script, a SQL query script file, and we've covered Python from hello world to manipulating data with pandas and the analytical libraries. So Python programming, Excel, SQL queries, and Power BI, Microsoft Power BI, are the tools that we've used, all leaning towards analyzing data.
Cool. Yeah. So for Python specifically, that this is a huge benefit is keeping track of your Python code in version control. But even for things like SQL scripts, like Don mentioned, test data, test sets, and even things that aren't really that you don't want to maintain explicit version control over, like Excel docs or whatever, you can store anything in here. You may not get the granularity of viewing, changes over time, like you would with something Microsoft like SharePoint for Excel docs or Word docs, but you can still maintain it and keep all of your documentation and files together. Where it really shines is explicit version control for software development. But like I said, there's a lot of things you can use it for. So, right off the get-go, what is Git? We kind of mentioned it already. It's a distributed version control system. Um, Version control or revision control or source control is kind of what the terms used to be. It's about managing multiple versions and maintaining a history of your code or documents, programs, etc. Pretty much, again, like Don said, all real world projects use some sort of version control. Git's really been around for a long time. It's been gaining more and more ubiquity over the last, I don't know, decade or so. Before that, there are other options out there: CVS, Subversion, SVN, Mercurial, and of course Git. There's some other one-offs too, but those are the big names, especially in enterprise. Uh, Git really has been widely adopted by the open source community. So it's public and it's cloud-based, and anybody can use it for free. You just have to create an account, or if you just want to consume stuff that's on Git, you don't even need an account. You can just pull it down. So open source is kind of where it shines, really, is you have, instead of a core team of developers working on some private project, you have distributed that source code to hundreds of thousands or millions of users who can contribute, offer feedback, report bugs, things like that. So why would we want to use version control? Well, if you're working by yourself, which throughout this course you probably have been, and even in your day-to-day at your job or internship or whatever, you may find yourself working alone. It gives you personally what I like to say is a time machine for going back to earlier versions. It's like Control Z or undo for your entire project. So you could test out new features or new ways of doing things, new algorithms, use new libraries or whatever in your code. And as long as you commit that code often to source control, you can go back to any point in time before you implemented something. If for whatever reason there were bugs or you didn't get the intended result, you could easily roll back to where you were before without having to save backup copies of your code somewhere else, rename it, just put it on a shared drive or a flash drive, stuff like that. When you're working with others, it greatly simplifies concurrent work. So if you're on a core team of analysts or developers and you're all working on a single code base, it could be challenging for you to pass files back and forth to one another, make changes, in one place and then hand it off to somebody else to make different changes, but in the same code base. When you use version control, you can all work independently on your own pieces and your own features and implementations. And then when you get ready to put that all back together, Git simplifies the way that you do that. It handles merging. Sometimes there's some action you have to take if there's conflicting merges, which we may talk about in a little while. But by and large, if you're not working on the same lines of code as somebody else, it's pretty much autopilot. When you merge your changes, it puts it together nicely, and you don't have to worry about overwriting somebody else's code. Which again, back to the open source community, open source projects, that's sort of how a lot of open source projects gain a foothold, is because, one person or small group develops some project and they develop under an open source license and they put it out there for the world to use however they want. And then another group of folks or individuals comes along and says, hey, that's cool, but I can see this feature being useful, and they can pull down that code base and they can write a feature, make some changes, fix a bug or whatever, and push that code back up to the original repository for everyone else to consume, which really distributes the workload, and it takes a lot of the pressure off of small organizations who have big ideas for a project, but don't necessarily have the staffing or budget or whatever to actively maintain or continue to develop some software. Even as an individual who doesn't have a full-time job already in this realm, if you're familiar with it, it gives you a leg up during your interview or on your resume, because most companies, whether they're tech companies or not, probably use some sort of version control somewhere in their company. As an analyst, you could probably use it by yourself, maintaining a history of the things that you're working on. But chances are, if it's a data science team or something like that within an organization, they're going to have a code base that's distributed for everyone to leverage. So if you know that going into it, you've got a leg up for sure. And like I said, Git is the most popular one now, but in general, the idea of version control, it isn't really tied to any particular flavor or option for version control. Just being familiar with the concepts, although the syntax and the way you do things differs between the different versions, Git and SVN, et cetera. The general idea of version control is something that you need to know if you're going to work in this world. So that's Git, and that's and we'll get into the history in a little bit. So that's what Git is. GitHub is a free public cloud-based implementation of Git that's available to the public. There are paid models for GitHub, but there are also free accounts that anyone can use. It has the largest collection of open source projects and community of developers on the web, and it looks great on the resume. So GitHub is just a place you can go to find or contribute to other projects or put your own projects out there. There are others that are out there that still leverage Git, but they're commercial. For example, Bitbucket is one that's owned by Atlassian. That's what we use at Axiom. It's an enterprise version of implementation of Git. So it's got the same core functionality as Git. You'll interact with it the same way as you do interacting with GitHub. But it's private and there's some additional security measures. And of course, there's a cost associated with it for enterprise support that GitHub doesn't necessarily provide. And the URL for that is just github.com. So within Git, your top level working directory contains everything about your project. If you have a large code base, there's probably many subdirectories, there's source codes, there's your compiled binaries, documentation, test data sets, all of that. Once you initialize a Git repository, it's going to create a hidden folder that starts with a dot, and that's how you signify it's hidden. .git. It's going to create that automatically, and anytime you interact with Git on your repository, it's going to make some changes inside that folder, but you don't ever really need to worry about what's going on in there. It's kind of like the metadata for your repository, where the software Git will take care of all that for you. Whenever you're working, you can take a snapshot of everything or specific things in your current project, and that's called a commit. So anytime you change a file or some test data or some documentation, you want to commit that change to your repository. And you can do as much or as little work as you want inside your repository or inside your directory, but the repository isn't updated itself until you commit those changes. And then typically inside your repository, you have a readme.md file, which is it's documentation for your project, and it's in the Markdown syntax, which is the .md extension. That's, a lot of popular forums use Markdown for formatting text, and Git is one implementation of that. So it's a basic text file that you can format in a specific way, and it'll display nicely on the GitHub project page. Okay, so say you have some code that you're already actively developing and you want to create a new Git repository out of that code. After you install Git, you would issue the git init command for initialization, and it will create that .git folder for you automatically, which again is hidden, so you don't ever need to go into it for anything. You continue to work on your project just as you normally would, making changes through whatever editor that you use. Nothing special to do. Most IDEs, if you're using one, VS Code or NetBeans, or I don't know what the common ones are for data analyst work. I don't know what you typically work inside for Java, like Eclipse, things like that. And even rich text editors like Notepad++ have integrated support or third-party plugins that interact with Git. So you don't really have to do anything on the command line unless you want to. I'm sort of old school, I guess, where I prefer to do things on the command line versus a GUI tool. So that's what we're going to look at today is the command line. And I feel that if you learn the command line syntax, you get a better understanding of what's going on behind the scenes, so that you could transition to a GUI to make it easier for you, but you still know what's going on behind, in case you need to troubleshoot or things like that. So when you're working on your project, and you're ready to make a commit, you would issue commands like this. So git add, some new file or some new folder, if you added a new file or new folder to your project. Or if you want to just commit everything, you would do git add asterisk or git add -- all for all changes that you've made. When you commit, you tell Git, your repository, that the changes that you've made are ready to be included in your project. So the saying goes, commits are cheap, so do them often. It doesn't cost you anything to do a commit. There's no data being transmitted. It's all local inside that .git folder. So it doesn't take a lot of time, resources, anything like that. So anytime you make a change, even if it's a small, minor documentation change or fixing a typo or a bug, you want to commit that often, so you have more snapshots, more points to roll back to in the event you need to. And if you hand off the project to somebody else, they can review the commit history and see what changes over time have been made to a particular project. When you do commit, you're required to include a commit message. Typically, it's one line. You want to keep it short and sweet. A bad example would be you fixed a bunch of things. A better would be you corrected the calculation of median scores. And again, that's so that a year down the road or 10 years down the road, somebody can go back and see at a point in time, what changes were made specifically. And as well as, just that high level message, you can drill down and compare the different versions of code, because it is all tracked, and see specifically what lines are changed and what the old version was compared to the new version. There are some implementations of Git that allow multi-line comments, but that's not the norm. You typically don't want to include a whole paragraph. If your commit message needs multiple sentences to explain what you did, chances are you should have committed more than once. So for each small change, commit. Again, commits are cheap, do them often. So, make a change, commit with a specific message, make another change, do another commit with a different message for the changes that you made. And to do that, you would issue the git commit command, and then the -m for your message, and then the message that you want associated with that commit. So one of the ways that Git differs from some other version control software is the fact that all repositories are treated as equal in Git. And what that means is, so in Subversion, for example, SVN, which is an older version control software, you have a centralized server with your code base on it. And in order to work on that code, you must first check out that piece of code from that server. And when you do that, it's locked. Nobody else can check it out. Nobody can pull it down. They can read it, but they can't make any changes to it. And if they do, they'll get an error. Git is different in that you have your central repository on GitHub, for example, or whatever implementation of Git there is, Bitbucket in our example at Axiom. But whenever you clone that repository down to your machine, you have the full history of that repository. You don't have a specific file of a specific version of a specific file. You have everything from start to finish. Now you can tell Git to only pull specific pieces or whatever, but the default is that you get everything. So whenever you clone a repository to your laptop, you have exactly what the server has. So if you wanted to go back and look at a commit that happened 2 years ago, you could do that on GitHub, or you could clone that repository and do it on your machine, just the same. The difference is when you make changes locally, you have to push those back up to that centralized repository so that everybody knows that changes were made. If you're only using the code for yourself, then you don't necessarily have to do that. You could maintain that code base, that repository, just on your machine and not push it up to GitHub if you didn't want. The downside there is if your computer dies or hard drive crashes or whatever, you lose all of that. Versus if you had committed that up to GitHub and stored it there, it's centralized and you can pull it from anywhere in the world from any machine if you want to look at it. So whenever you are making changes to a repository that's already existing, you would clone it first, which is basically pull a copy down to your machine. You would make your changes. You would commit those changes to your local repository. So using the git add and git commit commands that we just talked about. Then you could check to make sure somebody else hasn't changed or updated the centralized repository since you got a copy of it. And if they haven't, then you could push your changes back up to the central repository. If the central repo on GitHub has changed, then it's your responsibility to figure out how to merge those two versions. If the changes don't conflict with one another, it's going to handle that automatically when you do your push. It'll merge your pieces of code and you'll have a new version that has both changes that you and somebody else made. If you and somebody else change the same line differently, then it's going to pop back and say there's an error and you got to figure out which one you want to keep. And so that would require you reaching out to, whoever else is working on the project to say, which one of us, which one of these is what we're going to go with going forward. So in general, if you make sure that you're up to date with your centralized repository, make sure that you don't have any, if the central repo hasn't changed since you got your piece of code, and then you make some changes to your code, and then you update the central repository before anybody else does. If you push your changes back up there, you won't ever have to resolve any conflicts or having merge issues. So always do that whenever you're working on a code base that belongs to somebody else or that more than one developer are working on. Again, for you guys doing analyst work and you just want to keep track of your specific stuff, that's not really going to be an issue. You won't have to worry about merge conflicts. A couple of other concepts we want to talk about just briefly: forking, branching, and then pull and pull requests. So forking is when you create a new repository that's based on existing repository. So this is really common in open source projects where there's a project that's established and a developer wants to change the direction of that project, add some new features, do some custom branding, maybe commercialize that project if the license allows. They would fork that original repository and it would kind of break it off. And then they're free to change that new repository however they want, still maintaining the legacy code base and the legacy commits that have happened over time. So you move that version history with you, but it creates a separate stream of development. And this is pretty common in open source. So say some company has an open source project. Well, Bitbucket is an example. So Git is open source. What they had done is they took this open source project and the commercial license allows for this. They forked that implementation. They changed things significantly. They wrote some proprietary code to go along with it, and they commercialized it so that they can sell their flavor of Git to enterprises, and charge tens or hundreds of thousands of dollars a year for their specific features and architecture. Under the hood, it's still the core Git that GitHub uses, but it's implemented differently, and there's a reason that they can charge a lot of money for it, because they've had their own developers enhance it beyond the open source project. So that's what a fork is. Branching is similar, but it's a separate stream of development inside of an existing repository. where the development is focused on a particular feature or state of development. So say you have a repository and you want to add a new feature, you might create a separate branch for that, implement the feature in that branch so that it doesn't impact the main branch, the master branch. You could have a separate branch for different system compatibility, or if it's an app, maybe a branch for iOS and branch for Android. You could do bug fixes in a separate branch. And once the development is complete for that and all the bugs have been tested, you can merge that branch back into the master so that that's available for everyone. And then pull and pull requests. When a developer creates a fork or a branch and wants to incorporate their changes back into the original repository, they submit a pull request asking the owner of the original repository to approve those changes and pull them into the project. So, say there's an open source project that you're really passionate about and you want to contribute to. So say pandas, for example, it's the math library for Python. It's an open source project, so anybody can contribute to that code. Say you found a bug in it and you want to resolve that bug, you pull down the code, you make the change within the pandas repo or the pandas library, and you can submit a pull request back up to the original developers of that publicly available package. And if they approve it, your changes will get incorporated into the main repository, the master, and anybody that pulls down that code going forward will have your changes baked in there. So that's a way that, again, distributed development, anybody can work on any project basically, and get their changes pushed back upstream into the main project. Okay, so any questions so far? I know we kind of went pretty quick, but that's just all the high level stuff. And then we're going to do some demos so you get an understanding of, really what we're doing here.
Everybody good so far? Tracking. Okay.
Sounds like
Hey, Don.
Go ahead.
Hey, I've had an emergency come up here at work. I'm going to have to log off this one.
Well, I'm sorry to hear that, Seth. I'll post the recording this afternoon.
Okay, I'll make sure to watch it. Hey, thanks for giving the talk. I'll be back.
Okay. And that happens. Back to you, Justin.
All righty. Okay, so to actually get started with Git, what do you need to do? Well, if you're on Windows, you can go to github.com or actually just Google download Git, and there's an implementation for Windows. If you're on Linux or Mac, it may be a little bit different. I know there's package managers that you can use to install those, but it's a pretty straightforward install. Then you'll want to create a free account on github.com. And we'll go over there and see what that looks like here in a second. Then you'll enter these two commands at the command line for your Git. Again, there are GUI options, but we're just going to focus on the command line. And this tells Git who you are and what your email address is, so that any changes you make to any repository are attributed to you, and people can contact you if they so choose, or if you allow. You only need to do that once if you specify the global command here. So any changes you make in Git will have these attributed to them globally. You can also specify a specific repo if you're working on some project, open source project, and you choose to do it anonymously. For example, you could have a handle or a separate throwaway email here for that particular project. So say you have an existing code base and you've already installed Git, you've created an account. You would cd change directory into that project on the command line. Again, you would type git init like we talked about, and that's going to create that hidden .git folder with some metadata that's baked in there. Then you would do git add a period or an asterisk or dash dash all to add everything inside your working directory into your repository. And then you would commit that to your local repository. Typically, the first time you do it, initial commit is good enough for a message since you've already got an existing code base. But you don't, you can do whatever you want there. So that's creating a new repository based on code that you already have. If you want to clone somebody else's repository, that's pretty simple. On GitHub, you can either download the repo as a zip file and just extract it and start using it right away. If you want to interact with it as if it were a repository that you want to contribute to, you would clone it. So the git clone command, and then you would paste in the path to that repository, which GitHub will give you. And again, if you are working on a shared code base, always remember that you have to merge changes with others and resolve conflicts if you are working on the same piece of code. And then when you're done, you would push your code back upstream up to GitHub. So if you have a new project, you would create an empty repository on GitHub. You would follow the directions that it's going to give you to add the remote. So the remote is the repository URL on GitHub. So the git remote add, and then you would call it whatever you want. Origin is kind of the standard because that's where your code is going to originate from. And then give it the path to your Git repository that you create. And then after you do that, you push your code, your changes that you've committed. You do git push U for upstream to the origin, which is this. And master is the branch by default. If you are creating feature branches or bug fix branches, stuff like that, you might change that to push a different branch. But in general, master is probably what you would be using. So that's the quick and dirty of how to use Git. So now we'll do a demo and you can actually see how this works. So go to github.com, create a free account. There are paid versions, paid subscriptions to give you some more features, including additional private repositories. So by default, I think each account, you get a certain number of private repositories. I'm not sure what that number is. You can pay more and get more private repositories, but you can have an unlimited number of public repositories. And the difference is public repositories, anybody can see anything you put out there. So if you're working on some startup, you wouldn't want to put your code in a public repo. You would want it in a private one. So create an account, and then we can just click a new repository here and call it, we'll do hello world. Here's where you would choose if it's public or private. We will just do public. If it is a project where you are concerned about licensing, you can choose to attribute a specific license to it that maybe does or does not allow commercial use, things like that. I don't know what the most common is. It's probably the GPL, the general public license, or Creative Commons maybe. But you don't have to do that. And these other settings are optional. You can add a default README file. We're going to create one, so we won't do that. And then there's a .gitignore file, which if this file is present, then you can edit this file and tell Git to ignore specific files or folders within your repository. So if you have, a username and password stored in a file inside your folder, you wouldn't want to push that up to Git because then anybody could pull it down and have your credentials and wreak havoc. And that was, Don mentioned previously that I had some experience with AWS. That was a big issue early on in AWS, is people didn't really understand protecting their credentials like that. And so they would have their AWS credentials baked into a config file inside their repository. that gave them root access to their own AWS account, and they would push that code up to GitHub. And there are bots that crawl GitHub looking specifically for those credentials. And if they find them and they validate that they work, they could go spin up, a ton of servers on your AWS account, leaving you to foot the bill of $10, $20, $30,000 in a month, running some spam bots off of your account. So you can bypass that by adding that to your git ignore file so it doesn't get committed, or more importantly, don't store credentials in plain text right next to your code base. But that's one way to solve it. Okay, so we will create a repository, and when you do that, it's going to give you a little snapshot of what you can do here to help you get started. If you want to create a new repository, which is what we're going to do, you will do that. If you have an existing repository that you want to push here, you can do this, or you could import code, which if you use a different type of version control, it can handle the conversion for you, which is pretty neat. Okay, so what we're going to do is we're just going to create a new file. It's going to be a Python file. World. We're going to save that. In a new folder. Okay, so hello world.py. After you install Git, you'll have a couple things that get installed. You'll have the Git GUI, which again, I don't have any experience with. I've never really used it. That allows you to interact with a GUI. And then you'll have Git Bash on Windows anyway. On Linux and Mac OS, you probably won't get this because it's built in natively to the command line. If we run Git Bash, it's basically like a small Linux shell that runs on top of Windows that allows you to interact with Git. There's also the Git tool for Windows that you can run through PowerShell or the old, just the native command tool. But Git Bash is cool because you have some Linux tools at your disposal, but you also have the full the Git stuff here. Okay, so we're going to cd to where I have this code at. So cd, if you're not familiar, is command line tool to change directory. So we're going to cd to first, pwd is print working directory, so that tells you where you're currently at. So I'm currently in C users Justin, which on Windows maps to C:/users/Justin. So we're going to cd to documents/ACA/get demo/hello world. And that's going to put us in the same location as we are up here in the editor. And then we're going to do an ls, which is a directory listing. On Windows, it would be like a dir, same thing. And that tells us we have one file in here, hello world.py. So we're in the same place. If we come over to our little cheat sheet, we've made the directory, we created our hello world file, and then we're going to initialize a Git repository locally. So we'll just do git init. Okay, and you can see some things change. So it added this to our little prompt saying that we're in the master branch. If we had other branches, we could change between them. And this would update accordingly, but we're not going to worry about that. And you can see it created an empty Git repository here with this .git folder. So if we go look back here, you can see we have this .git folder that's kind of grayed out. On Windows, that indicates that it's hidden. If you don't see it, you can go up to View and then tick the hidden items box. If you don't have it ticked, that won't show up. But again, you'll never need to go in here. But just for reference, this is the kind of stuff that's in there. It's all metadata that Git knows how to interpret, and you'll never need to do anything in here. On Linux, you can give it the -la command, so ls -la, and that'll give you, the A is to display hidden. So that'll show us our .git folder here. Same thing. Okay, so then we need to tell Git who we are, which I've already done this, but we'll do it again. So we can just copy and paste this, the git config global user.name. User.email. Okay, now we're ready to add the file that we created, this hello world.py, to our repository. So git add, you can either do asterisk or -- all, just a period for the current directory. I usually do -- all. That's just kind of my preference. Okay. And then we need to add our remote. So if we go back to GitHub, this would be the copy or the path to your remote of whatever repository. And typically it's github.com/your username, whatever you created, and then the name of the repository that you created, .git. Which it should be the same as here. So git remote add, we're going to call it origin, and then we're going to give it that path. Okay. And then after we've added our origin, we've staged our files or added our files locally to the repository. Now we need to commit them to the repository. So we get -m for our message, and we'll say this is commit. Okay, it says one file changed, one file was inserted, and that file is hello world.py. So now our local copy of the repository is totally up to date. Our files in there, our changes are in there. Now we need to push that up to GitHub. If we go back and look at this repository, even though we committed, we still have an empty repository here with this welcome screen, basically. To get the code up there, we have to push it. And again, it tells you basically how to do that right here. So after the commit, we'll do a push. We'll push you to the origin, which again is this remote that we created right here. That's where we're going. And we're pushing the master branch, which is the default. And that's the branch that we're working with. The first time you do it, it'll probably pop up and either prompt you for your username and password to GitHub, or ask you to install or authorize some credential helper. I've already done that on this machine, so it's not going to do that, but it probably will. And if you set up two-factor authentication or something like that on your account, you'll probably have to enter your token.
So Justin, can I jump in for just a sec?
Sure.
Something that's probably escaped me, and I'm not a Git user. I pull cool stuff off of GitHub when I find it. The commit though, that's saving your changes to your local repo.
That's right.
Not up to, so the push is where you actually post it up to the public repo on GitHub.
Right, exactly.
Gotcha.
And that goes back to the idea that in Git, all repositories are created equal. So they say your local repository after you commit is no different than the repository that's on GitHub. You have the full history of everything since the inception of the repository locally. After you commit those changes to your local, the push commits, it pushes your commits back up to your remote.
Gotcha.
Okay. Okay, so we committed our changes locally, one file, one insertion, and then we pushed those from the master branch, which is where we're working, to the origin, which again is this remote up here. And now if we go back to GitHub and refresh our repo, you can see that we have our commit message here. It was 3 minutes ago, and it's hello world.py, and we can drill into it and see the contents of that file. You can see we have one contributor. If we had multiple people committing to this project, we would have all of them listed, and you could go view their profiles. You can see the full history of your commits here, and we only have one so far. And so that's how you get code up here, up into GitHub. It's pretty straightforward. Once you do it a couple times, the commands just kind of become second nature. First you add, then you commit, and then you push. Adding your remote is something you only have to do once also per repository. If you're working on multiple repositories, you would add these for each one, and Git, depending on what folder you're in, Git would know which one. And that's one of those things that's stored in that .git folder. So if I, well, actually we can do that. So let's do this. Let's go back a level, and we're going to make a new directory, 2, and then we're going to go at, okay, so oops, I messed that up. Hang on. I accidentally created that back in this Git demo folder. So I'm going to just drag that into the new folder we created. So now we have Hello World, which has our Git repository with that initial file we created. And we've got Hello World 2, which just has this new file that I created by echoing Hello World again to that file. And excuse me for 1 second. Sorry. Sorry, kids were getting a little loud out there. Okay, so we have 2 projects now. So now we're going to do the same thing again. We're going to cd into Hello World 2. We're going to do git init. So we have an empty repository. We're going to git add all. This is just a Windows and Linux thing. Line feed is a new line. CRLF is the Windows flavor of a new line. It just depends on how the file's created. Sometimes you'll get that, but you can ignore it. And then we're going to go back here, and we're going to create a second repository. Everything else the same, public. And this is our remote for this new repository. So if we come back in here and do git remote origin, same thing. So we're calling it the same thing, but it's just got a different URL. So you can do git remote -v, and it'll list all of the remotes that you have configured for the repository you're in. So in this repository, Hello World 2, it lists these as your remotes for fetch and push, which are the same. You don't have to worry about that, but they're both called origin. If we go back a level and go into Hello World, which is our original repository, you can see that they're still called origin, but they don't overlap. So they're stored per repository. So the folder is different, or the path is different here, although they have the same name. So that's how you can work on multiple repositories all at once without, stepping on the toes of something else that you're working on. Git tracks all of that for you inside that .git folder. And just for consistency, we can go ahead and make those changes in our new repository. The origin on our master branch again in the Hello World 2 project, which is this repository here. And again, it goes through successfully. And if we refresh this, we should see the same thing. So now we have 2 repositories, Hello World and Hello World 2. Okay, so if you want to track your changes in Git, that's how you do it at a high level. Any questions about that? Okay, sounds like a no. Like Don alluded to, you don't have to necessarily be pushing code to GitHub, although it is a great thing to do, and that's kind of what's intended for, to get value out of it. So, like I mentioned, GitHub has the largest collection of open source software on the web. So if there's something that you're looking for, if there's some example, if there's something, some pet project you have, there's a good chance that there's code out there already that does something similar, if not the exact thing that you're looking for. So you can, come out here and just search.
I've got a real world one, Justin. If you could,
yeah, sure.
go to it's Python data science, but the repo is Jake VDP, Jake Vandenplas. So it's Jake Victor Delta Papa. Yeah, there you go.
So I think you pointed me to that one last time. That's why it was in my search history.
It was in your memory. Yeah. Guys, this is data science. It's above and beyond analytics and reporting, but it's a book. It's one of those O'Reilly books with the animal on the cover that you see ubiquitously. Yeah, there's the so it's got the Gila monster on there, but he has written this book as a series of Jupyter notebooks, which you're all very familiar with. And so that you can download or you can clone his repo, and have it on your local machine so that you can goof around with the notebooks, and it's markdown encode just like our lessons and whatnot. But it seems like at the bottom, he makes a comment about Git. You should use Git. It'll make all of your life easier. But it may not be in this repo. It may have been in another one I was looking at. But he makes a pitch for using Git and forking this instead of, or forking it or branching it.
Yeah, so
cloning it.
Either way, so you could clone it and just work on it locally, or you could fork it and make use of Git and push any changes that you made back up to your own repo. So if we kind of look at this project page here, you can see that there have been almost 16,000 people that have forked this repository to manipulate on their own without, you do that so you don't change this repository. Not that you could, you wouldn't have the permissions to do that. But so you can track it, publicly or privately if you want it. So to create a fork, it's pretty easy. You just go to fork and create new, and we're going to fork it as my account and call it the same thing. You can copy the master branch only, or if there are other branches that you're interested in, you could untick that and it would get everything. So if we fork it, you can see it takes us back to my account. And we have everything that's here. We've got the full 234 commit history in my repository. And we could go probably, let's see, dig into here and you could see, let's see, pick just any arbitrary commit. And, on August 28th, 2018, Jake made this change. He changed this comment from this in the red to this in the green. And then he added, these commands here. So you have that full transparency of everything that's happened in the project. But now it's in your repository. So you could clone this. So let's go back and do that. We're going to go. Oh. Okay, I guess it looked like it was loading, but it was done. So this is my repository that I have full control over. It was forked from his. So if we go to code, we can download the zip, like I said, which will just give you the files, everything you need. And if you just want to consume it, that's all you have to do. If you want to interact with it as a repository, though, you'd need to clone it. So you would copy. Sorry, were you going to say something, Don?
Yeah, we for most folks, unless you are savvy with Git and GitHub and you're doing this for a reason. For most of us, if we just want to, like you said, if we just want to use the resources out there on GitHub, download zip will create what I'm looking at. That's what's in the zip file, is those folders and those files underneath the underneath this
exactly
picture there. Yeah.
Yep. So if we open this and maybe it's thinking about it.
And clone creates a local copy on your workstation.
Yes, it creates. So the distinction between downloading the zip and a clone is the zip. What you're going to get is exactly what you see on Git. You're going to get the latest version of the book and the notebooks and all of that. And that's it. That's all you're going to get. If you clone it, you're going to get on your local machine the full history of these 234 commits. And so you can do with that, what you will.
Gotcha.
So say, let's see. Well, we can. How much time do we have? We're pretty close to time here, aren't we?
Yeah.
Okay,
I mean,
well,
at your convenience, you know what I mean? If you got to jump, for sure.
no, I got a couple extra minutes. I was just going to kind of play out the distinction here. Let me make sure I've finished. Okay, yeah. So let's get rid of that. Go back here. Okay, so we downloaded the zip, and so that's one way to do it. So we're going to copy this clone URL here, and then we're going to go CD again back a level, which is .. in Linux and Windows. So that's going to put me in this Git demo. If I do an ls, this is what I have here. So if I just do git clone and paste that URL, it's going to pull it again from my repository, not his, because I forked it. And it's going to take a minute because my internet is terrible here at the house. So if we do an ls, we have the full on data science handbook. Looking at it here, you're only going to see that latest copy because we're in the master branch and we're at the highest commit. Okay. If we go here to the zip file, and if I extract this to here, name it download. Okay, so now we have two. We have the one that I downloaded as a zip file, and then we have the one that I cloned. If we go into the download one, you can see we have just the latest copy of everything. We don't have that .git folder because it's not a Git repo. It's just a bunch of files. Git init on a new folder. We could do git everything. We could do git a message initial commit download. And we could go back out here. I could go back to my account repository. Again, this is the one that we forked here. So if I create a new one, call it, what is it? Handbook. Accept all the defaults. We're going to copy this. Remote add origin to this new repository. Push you to the origin from our master branch, and then we'll look at the difference in GitHub. And again, terrible internet, might take a minute. Okay, so if we refresh this, again, this is the one that I downloaded, the zip file.
Mhm.
We have one commit, and the only thing in that commit is the latest copy of each of those files. If we go look at the one that I forked here, still in my my account, but we have that full commit history. So that kind of demonstrates the difference of just downloading the file versus cloning the repository. So again, if you just want to consume this, use it as it is, and that's it, then yeah, downloading the zip file, extracting it, and have at it. That's perfectly fine. If you want to modify this in any way, you'd be better served cloning the repository. Well, forking it first, so you have your own repository to commit to, and then cloning that down locally, making your changes, and then committing those changes and pushing them back up to your local repository. Does that all make sense?
Yeah, I'm thinking of a few times and places where I probably should have forked somebody else's repo that they quit working on. Basically, there's some Python stuff out there that I've seen that they basically quit before they really completed what they were doing, kind of.
And that's kind of the beauty of open source projects, right? Like if somebody abandons something and you see real value in it, you're free to fork that and continue developing on it and put it back out there for the rest of the world to consume at some point. Because there's plenty of things like that, right? Like if we look at and I'll full disclosure, I don't use Git just a ton because I don't have much time for personal projects these days. But like the repositories that I have, messed with. So this is firmware for my 3D printer. It's all open source, and I've made some changes to it that suits my needs. So I've forked these public repos and committed my changes to them. And there's some demo stuff that I've done, and I've done some projects for the makerspace at UCA, and we keep that out here. So yeah, this is a good example of something that's public that I've forked and made my own changes to that aren't really applicable to the rest of the world that's using this because it's specific to my particular use case. So there's no reason for me to try to push my changes back up to this public repo because it's not going to benefit everybody else. If you fork it and then push it back up to your own public repository, if people want to use it, they can. It's there, it's public. But really, for me, it's just about tracking my own changes.
And I take it you'd have to get a little bit smarter with the licensing before you start forking and modifying and reposting. But
yeah, probably chances are if it's on GitHub, it's an open source for personal use, more than likely. There's a bunch of different licenses that apply to it, and I do not know one from the other. Really, when you're going to get into hot water, though, is if you try to make money off of it. If you try to commercialize it in any way, you really need to be well versed in the licenses that things like if we try to take, Jake's data science handbook and lift some of his Jupyter notebooks out there and sell them, that's more than likely a violation of the MIT license that this is open under.
Or like he sells it in print form. I'm sure if you self-published your own or whatever.
Yeah.
So
wouldn't go great.
So guys, we are running a little short on especially Justin's time here. Are any questions or even confirmatory comments? Are you guys using any sort of version control GitHub at work?
I am not, but developers here do use Git. I'm not a developer, so.
I'm curious if you'll see some cross pollination, because I think that's the way it is for a lot of analytics shops. They just stuff's out on the shared drive and they do the best they can to maintain version control and not use the wrong file or the old version of whatever.
Yeah,
But
sure.
I think you're
Old
starting.
old school version control is like, well, I want to change this file and it's 600 lines of code. So instead of version control, I'm just going to copy it and rename this to
Yeah.
2022 08 11.
Yeah.
And there's still a time and place for that, right? Like there's things that I work on the day-to-day that are so small and insignificant they don't necessarily belong in version control. And so when we make minor changes, yeah, we'll create a backup and do it like this. But anything of any substance you want to track with proper version control. That's my opinion, at least.
And especially if you're collaborating with someone or
Yep.
half a dozen people, or like a lot of these folks are in an analytics team, where it very well could turn out that somebody picks up your work, or there's more than one person working on different segments of a project. So
yeah. And so looking back at Jake's here, so he's got 16 contributors. These are 16 individuals that he may be associated with personally, or maybe they're just part of the open source community that want to make additions to his project, and he's allowed them to do so. So they would fork this repo, they would make their changes, they would push those changes to their own repo, and then they would come over here and create a pull request, which there's 89 pending. So these are commits from contributors saying, hey, I made a change. This is the content of the change. This is what I did. And if you drill into these, you'll see exactly which lines were changed. Can you please approve these changes to go into your main repository? And sometimes that's perfectly fine. Sometimes it doesn't necessarily belong there. Sometimes it's better to stay in a forked repo or in a branch versus the main master repository. And so I could create one. I could make a change to his notebook that I just forked, and I could create a pull request and say, hey, can you merge my changes from my fork up to yours, because I think it would benefit the world. And if he agreed, he could do that, and then my code would become part of the repository that everybody else pulls down going forward.
There you go. Dexter, you came off mute there for a minute. Did you have a question or a comment?
Yes, sir. I was gonna say, from time to time, they show us some of the projects that are identical that they be working on GitHub as tutorials, because I don't have right access to any code. So they give us little links and stuff for us to go through and on GitHub to see what they actually working on. Because sometimes it be so complex. Like, man, what is this? You have to ask a billion questions while we shadowing. So they give us these links to these sources on GitHub a lot of times.
Yeah, and that's a great way to maintain, training documentation. There are, enterprise solutions for version control of documentation specifically. But if you've got code and document that lives together, GitHub is a great place for that. And so kind of circling back to, the wealth of projects that are available out here. If you have something that you're interested in, so I dabble in Raspberry Pi stuff, there's 94,000 repositories that relate to Raspberry Pi, different projects that people have created. So there's TensorFlow if you want to do machine learning on Raspberry Pi. You can pull down these examples and get started right away without having to do a ton of upfront development work on your own.
Magic.
Pretty much. I mean, anything that you could dream of doing, there's probably a Git repo that is somewhat related, and it's at least a jumping off point for new things for you. So I highly encourage you, even if you don't actively use it for your own projects, get out there and poke around. If there's something that you're interested in learning more about, just search it, and chances are there's something out there related to it.
There you go. Okay. Well, Justin, if nobody else has any questions, comments, I'm going to thank you and let you go. And then I just got a couple of comments for the group before we adjourn for the day.
So I will go ahead and post a couple links in the chat here to the PowerPoint slide and that little text document that had the commands. that people are welcome to go out there and download if they want to play with it on their own.
Cool.
My email address is baked in there into that text document. So if you have any questions or need help getting set up, feel free to email me. I can't promise a response right away, but I will eventually get back to you.
Okay. And we sure appreciate your support on the MariaDB, which is a fork of MySQL from years and years and years ago. Apparently one of the main guys with MySQL didn't like the way that project was going. So he forked their repo, and now we have
and that's a prime
completely
example.
different, completely different version.
MySQL started out open source, and then eventually Oracle bought the product, and it was forked off to stay open source as MariaDB. So as far as I know, it's 100% compatible with MySQL. You just don't get some of the more enterprise features that Oracle has baked in to warrant charging money for it. So yeah, that's a great example of it.
Yeah, I haven't found, it seems like if you find the MySQL syntax for something, it will work on MariaDB. So, and Workbench, of course, works with it.
Yeah,
So
and I think the differences are all in the back end. From an end user perspective, I don't think there's any difference. I think they're 100% compatible syntax wise.
There you go. All right. Well, thanks again, Justin.
Yeah, absolutely. You guys take care.
Okay. All right, guys. This concludes any formal class meetings. If you need help with your projects, I'm an email away. I'm still working for ACDS. It's just that I won't bother you to get together for anything in particular. Hopefully you use the last couple days to continue with your training and didn't let yourself get sucked back into the mayhem at work. I have updated the classroom quite a bit. Let me share my screen. Am I sharing my screen? My whole screen?
Yes.
Cool.
Yeah.
All right. Look at all of these class sessions that we've been together. Look at all of these recordings. The hours and hours we've spent together are coming to a close. So if you shed a little bit of a tear right now, thinking that you're not going to be able to hear my calm, soothing baritone every Tuesday and Thursday morning, I understand. I understand, guys. So didn't change much in foundations, but I did add the project review that we went over with your mentors. So I added those slides, added a little bit to Excel. These are some resources that you might find, lots of like cheat sheets where it lists like every formula, every function, and examples of how to use them, some advanced spreadsheet skills. Thought that was pretty handy. I added a whole bunch of stuff down here to Power BI. These PBIX samples are things that Microsoft hides on their document website. So I went ahead and pulled them out and put them up here. But you can see those are they're fairly extensive reports, and of course, since it's Power BI, the data is kind of included in and amongst the project. And those are some particular applications of Power BI, an HR dashboard and a sales and marketing dashboard. So yeah, so there's those you can take advantage of. I added some underlying I don't know, theoretical, academic sort of information. Here's a session of Mr. Bill Shander did for me a couple of cohorts ago. He's he comes from psychology, but he does a whole lot of data storytelling and statistics and just great lessons out on LinkedIn Learning. If you Google Bill Shander on LinkedIn Learning, you'll see he's got a whole bunch of coursework out there. I added a link to Gestalt principles. These are data. This is all data visualization underlying stuff. And then a Power BI tutorial document that's huge. It's a little outdated. Some of the buttonology has changed, but there's just a ton of information there. And I added Cameron's GitHub repository, the link to all the materials that he used in our MongoDB course. Got to publish that. And publish. There we go. Okay. Now, did anybody find, or I'll stop sharing my screen. Anybody find or want to share any last minute extra resources or tutorials or more in-depth stuff that you might have learned over the past couple of days when I turned you loose to do your own thing? Going once, going twice.
I can share the course that Jeanette and I did on Udemy for Power BI. It walked you through like beginner things and also some DAX stuff, which was really helpful in like understanding how Power BI works. So I'm gonna look it up and share the link.
Yeah, and post it in the chat, and I'll provide those links, including the links from Justin here. Yeah, Udemy it has just a ton of videos, and they must be paying Google to put their stuff up because you see them really high in the search results. Generally speaking, I've seen courses there for, I don't know, it's like a one-time fee, like $15. I subscribe to LinkedIn Learning and Pluralsight. And they both contain a wealth of information, but there's a bunch of stuff for free here in the classroom. And then if you just, hit the old Google, ton of Python stuff for free. Like I showed you that Jake VDP, Jake Vandenplas. He's got a whirlwind tour of Python. If you're already a programmer and you want to get into Python data analysis, he's got a series of notebooks that walk you through Python syntax, and he's got a scikit-learn, so a machine learning tutorial as well. All right, cool. So everybody that's live has that in the chat, and I'll post that to the classroom under additional resources. Okay, guys. Keep in touch if there's anything going on that's stressing you out about your capstone project. I'll shoot an email here in the next day or two to you and your mentors, inviting you specifically to 9 to 11 on Thursday, the 25th, 2 weeks from today. Any parting wisdom, comments? Alyssa, you're going to organize the class reunion next year, right?
Sure.
Okay. All right, guys. I had fun. Hope you did too. Hope you learned something. And at any time, for any reason, feel free to reach out, and I'm here to help. Signing off from North Little Rock.
Thank you.